all the people out there who want to digitalize their work, they only have to learn one low-code language to remote control the technology that they normally use in the background.
How would you decide if you automate something with low-code versus a programming language?
The goal with low-code is really to empower engineers who are not computer science experts, but empower them in a way that they can more or less playful program their working steps. We are able to convince people who would never thought they would become a programmer at the end, and with low-code they jumped into this field.
People maybe had some kind of mindset issues to adopt automation, and how did you overcome them?
This is the important mindset shift you have to bring. We are not talking about drawing the same line or picking the same element or whatever. It's more about one level higher. We have workflows from companies. They are run only one or twice a year. But if they get run, they save hundreds of thousands, maybe even millions.
Daniel, finally you made it to the podcast. Welcome.
Woohoo! Thanks. So glad to be here.
Yeah, really good. Today we'll talk about CAE automation, what that means, and then with a particular focus on FE automation. But before we jump into the nitty-gritty, can you give us kind of a quick overview, like who's Daniel in the first place and what is Synera doing?
Oh, sure. So yeah, first of all, welcome from my end. I'm Daniel, one of the co-founder and co-CEOs of Synera. A long time ago, I studied biomimetics, then Master of Business and Engineering. I love computer science, so I would describe myself as a product guy with a very generalistic interest and overview in technology and innovation. I'm working at Synera mainly in the product field, so I am responsible for the whole R&D department, but also for existing and exciting new business. And really glad to be here and talk today a little bit about CAE automation, as this is one of our sweet spot at Synera. Synera is a low-code programming language, especially designed for the engineers. So the idea is that the engineer themselves are able to digitalize their work, that they can reuse it and even share their work with others.
Yeah, that was a perfect pitch. Really good. I think it might make sense to talk about kind of the status quo in terms of CAE automation. I mean, we can talk about the benefits, what you can automate, how you automate it, etc. But I think, Daniel, it might make sense to give kind of an overview of what's the status quo of CAE automation, why are engineers struggling to automate certain tasks, and why they are stuck with like never change a running system mindset.
Yeah, good question. I mean, CAE automation is a big term. And my experience is when you're talking to people and you ask about, okay, do you have a recurrent task or do you have something that is worth to automate? Normally they say, oh, well, every project is different and it really depends. It's very hard to do always the same. And sometimes you change this, sometimes you change that. And therefore I see not so much automation, to be honest, at a lot of companies. If they do automation, then it goes more in the field of scripting, something maybe you're familiar with macros in the office domain, but also when you come to CAE tools like, I don't know, Altair or Ansys, you sometimes hear technology like TCL scripting for example, Altair, or in the Ansys domain, for example, RPDL. Interesting is that over the last couple of years, more and more Python becomes a rising star. I mean, probably due to the fact that it was already a very good scientific programming language. More and more programs also adapt to it. But again, it's very, you have to deep dive into these automation languages, and every tool has slightly different approaches. And so I would say the barrier to automate a task is very high.
Mm-hmm. How would you decide if you automate something with low code versus a programming language or scripting language?
Mm-hmm. I mean, in general, the biggest difference between low code and I think programming language is the entry barrier. So the goal with low code is really to empower engineers who are not computer science experts, but empower them in a way that they can more or less playful program their working steps. And with low code, you have, I would say, an even higher abstraction layer, which gives you faster success moments. So you can build with only a friction of onboarding already great automation sequences, as when you deep dive into more, let's call it script-orientated languages, you really have to learn the script language. You really have to understand programming a little bit more into detail. And then I think the barrier is normally higher. And I see it also that with low code, we are able to convince people who would never thought they would become a programmer at the end. And with low code, they jumped into this field.
Would it also make sense to say, or valid to say, that once you've built your workflow in low code, it's much easier to what you've already programmed to just transfer to other departments or share with other departments, so you don't just send your script via email, which comes to be quite tedious?
Yeah, I mean, that is something that we also discovered at Synera. So, I mean, one thing is that you develop your automation for yourself. The gold standard is that you create an automation which is so robust and so generalistic that you can share it with your coworkers, and that they can also benefit from this automation. And you mentioned an important aspect, so how to make sure that the other person is also able to use your technology and how to maintain all this stuff. And for sure, computer science and scripts, you can do it, but it's a lot of effort, because then you almost have to set up all the computer science orientated stuff. Like you need a pipeline, you need quality assurance, you need probably an onboarding for the user who wants to use your script. You have to make sure that all the environment is installed, etc. pp. And with low code, and also in our case with Synera, we tried to make it as simple as possible. So when you have your automation done for yourself, you can mark the inputs and outputs that you are normally, so the inputs are normally the things that you ask the other person in a meeting to say, please give me the material specification, please give me the boundary conditions, please give me certain criteria. So normally what you have in a tech spec. And then the person where you're doing the CAE automation for normally wants to get certain result types. So that would be your outputs. And with low code, you can then define, these are my outputs, I need to run my work, and these are the outputs I will provide afterwards. And then with just one click on deploy, you can put your low-code environment into a web application, and then this web application is easy deployable, and everyone in the company can just use it.
Also, I think for the engineers, it's also attractive if we talk about the marketplace. You have different integrations that can feed into this workflow. So once you've kind of built the workflow, integrated the softwares that you're actually using, I think you have a whole ecosystem that you can share across departments and also entire organizations.
Yeah. So that is also something. I mean, you ask about the difference between low code and the automation potential in the different tools. I mean, the great thing is all the CAE tools, most of them, they already have the possibility to automate. But as mentioned, everyone did it slightly different. So the real gold standard is if you want to automate across tools, right? So if you want to, I don't know, have some certain automation in the CAD, then you have some certain automation in a simulation, maybe a static simulation, then you have some automation in some costing tools, and all use different scripting languages. So the question is really, with low code and the marketplace you mentioned, we try to make one unified language. That means that all the people out there who want to digitalize their work, they only have to learn one low-code language to remote control the technology that they normally use in the background, and they also should continue using it. So our goal is not to reinvent the wheel. We really believe in an open platform approach, and we really believe that there's already great technology available. We just want to bring them all together in a way that you can digitalize your working steps in a way that you can reuse it and share it. So back to the marketplace, especially when we talk about CAE automation, there's a lot of different solver technologies available in the market. The biggest ones are like an Nastran, an Ansys, an OptiStruct, an Abacus, a Dyner. And again, we believe it's great to have these different technologies, and it makes sense that these technologies are accessible through a unified language with the power of low code.
Yeah, that makes a lot of sense. I'm wondering, from like a small and medium-sized enterprise up to very large corporations, do you feel that there's a difference in terms of automation pains, or do they have similar pains like scripting and or streamlining workflows? Do you feel that there's like similar pains that you're solving with Synera, or they're vastly different across organizations?
I think if you have a larger enterprise, sometimes you see a method and tool department, and then you see that they have a lot of scripts already. But mainly what also interesting for me, a lot of them was also like CAD macros, like in CATIA or in NX. And then you have these, and this is more like centralized. So for my opinion, there's more like this, okay, there's this tool department and they help them creating these macros. And then maybe also from a historical point of view, as CAE, especially the early days, it was very scripty, very text editor orientated. The people who do automation for let's call it simulation, they normally created the helper for themselves, but they are not really sharing it. So it means when you have your tools, you have your own little utility helpers for pre-processing or post-processing, but that's it. So back to the question, what is the difference between a larger and a smaller size company? I would say for larger enterprises, you definitely have this more centralized tools and methods department. They're normally focusing on single software solutions and automate these, but sometimes they also have computer science projects with a larger or with a higher programming language. And for small and medium-sized companies, it really depends on the single persons, right? So for sure, you normally have, I don't know, you have 10 people in your team, and normally you have 2 people who are script affine and they write some little helpers, or you have a thesis student, or you have a PhD in your team. The biggest problem what we see is here that it's very hard to maintain and make sure that these scripts and little helpers survive over, I don't know, a decade or at least a larger time frame, because normally it's very people orientated, these kind of developments in smaller ones.
Yeah, that makes sense. Could you talk about maybe some anecdotes that you've encountered during your work at Synera where people maybe had some kind of mindset issues to adopt automation, and how did you overcome them? Doesn't matter which size the company was. But is it mostly a mindset problem, or is it more like, oh no, okay, we don't want to change the running system, maybe the IT department is kind of against it?
I mean, a new technology always has this kind of, okay, there are thousands reasons why this should fail, and there's also thousands reasons why we already tried it in the past and we were sure that this will not be successful. But yeah, I think the number one objection is definitely something, okay, I cannot believe that this is automatable, because every time is different, every project is different, every part is different. We are doing development here. Why are we able to automate stuff?
Yeah.
And I think this is the important mindset shift you have to bring. Is we are not talking about drawing the same line or picking the same element or whatever. It's more about one level higher. It's like, okay, normally I get data from someone. Normally I do pre-processing, like I import something, I checked it, I make defeaturing, I make meshing, I make a boundary condition setup, I make connection points, I have maybe some super elements, whatever. And then I do a solver call, then I do a post-processing. And when these steps in general are very similar, and normally when you talk to CAE guys, and especially FEA persons, the steps are normally very similar. For sure, sometimes you make it with with a suspension arm, and next time you do it with a struct brace. So the part is different, but the methodology and how you do it is very similar.
But isn't that also a big advantage or like USP of Synera, because you think of it more like from a high level? So everything is replicable to different parts, different components, which is, I think, is super powerful.
Exactly. I think first of all, you have to be open to think about, okay, let's give it a try. We want to automate this. And then you have to ask the right question, right? You have to ask, okay, why do you clicking the surface? Okay, I click the surface because I want to set up the boundary condition. Okay, why do you know that this surface is a boundary condition? Yeah, because it's a bolt. Okay, so we need a bolt identification algorithm which is able to get all the bolts, and all your other parts you did over the last 5 years. Do they also have bolts? Oh yeah, 80%. Okay, so we need another edge case. If 80% is bolts, we need maybe another 20% for others. And this is how you build your automation. You normally start small with some utility, maybe only defeaturing or only solver call or only reporting in a post-processing, but then you can grow very good. And what you can do then is what you also mentioned is you can recycle very fast, right? So you can, I mean, it's copy paste, right? It's not that you click on file, new document, you say file, new workflow, but you open the last workflow and you copy 80% of the workflow and you adjust the steps that might be different in this. And if you really want to bring it to the next level, then you copy it, make an edge condition and say, okay, when this is, do that, and when this is, do that. And you still maintain your master method, which is then your general, in best case, end-to-end simulation.
That makes sense. One of the things that you mentioned, or one of the things we see on the website is that FE automation is at the very top in terms of applications. I think there has gone a lot of brain power into why FE automation and not like, for example, CFD automation. Could you explain from a product point of view, why did you decide to go for FE automation? Was it because of an imbalance in the industry, or like, is it the most requested feature or module? How did you go about this?
I think it was more learning by doing. So we introduced Synera roughly, we founded the company 280, so it's 6 years ago. I think the first 2 years was more like an alpha version, but since 4 years, you can really use Synera in your products and projects. And as a programming language, you can imagine that everyone has his ideas how to automate stuff, right? From, I don't know, a visual bill of material to a part comparison algorithm to generative design to simulation. But so we let it a little bit open and see what people trying to achieve and what kind of ideas they had. And so we did a lot of these kind of, we call it use case discovery, where we talk to a lot of different people in a lot of different industries and ask about, okay, where do you have repetitive tasks across different tools, and maybe even with your own routines or own scripts, and how often do you have this? So when they have it, pretty often, then it's probably a pain or something good to automate. And it figured out that especially let's call it the simulation results based on a new design is something which almost every company in the development has. So that means also, I would say 8 out of 10 customers have one of these workflows in production, or at least building these or using this on a very frequent period.
Yeah, that makes sense. I'm wondering, when do you recommend to a prospect or client when it makes sense to integrate low-code solutions? Because I feel there's of course this kind of activation energy or that bump that you have to go over.
For sure.
But when does it make sense? Like, how often do I have to automate stuff to then decide, okay, I'm just building it one time into Synera or in Synera and have to never automate again, scripting wise?
Very good question. So there are tasks when a prospect is telling me, okay, we're doing this once a year and it saves us 1 hour. I already can say, okay, this is probably not the sweet spot where you should use Synera, because I mean, Synera also brings some license costs for sure, and you need somehow, everyone wants in these days a positive business case, right? So it's very important that you get, I don't know, a multiple of the cost into a value. So there's not this kind of rule of thumb, okay, this is working or this is not working. So just to maybe tell you some anecdotes, we have workflows from companies. They are run only 1 or twice a year. But if they get run, they save hundreds of thousands, maybe even million. And this, I mean, they also need an investment to build this automation, but it's insane. But we also have very small helper, we call them utilities. And a lot of them are created by our customers on self-motivation, is that they're run maybe on a daily basis, maybe only to save 10 seconds or 20 seconds. But the sheer amount of executions justify that it makes sense to automate this stuff. So I think the best case to evaluate if something makes sense for you to automate is, look, how often do you run it and how much savings per run do you have? This is a very good, let's call it, maybe it's a rule of thumb to get closer to it if it makes sense or not. But this is then more like, okay, the real numbers, you compare the current effort versus the effort you gained through automation, and then you have to balance in, okay, how much work is it to build the automation, right? As you mentioned, the activity or the activation energy you mentioned, right? How much effort do I have to build, or how much effort I have to bring into the system to make a robust automation possible? And you have a lot of other added values when you do automation, right? One is that you save manual work, but the other one is that you also speed up product development a lot. Because normally, especially when you have handshakes across different departments or different tools, you have normally different people involved. And this means you normally, beside the sheer effort, you also have tools like lead time, right? So it could be that I'm a CAD guy, I want to get a simulation result back, but the simulation effort is maybe only 2 hours, but I'm in the backlog of the simulation guy, right? So it means that it could be that the effort is just 2 hours, but I have to wait 2 weeks to get my results back. And this is in some areas very critical. And this is also another motivation why automation, and then it goes more in the field of democratization, so that maybe the CAD person is even able to run this workflow on its own to really cut off the lead time. But then there's other motivation than just save the manual steps, right? It's really about to also have a competitive advantage by reducing lead time. Mm-hmm. And especially, I think we're living in a world where, we assume that everything goes faster, right? So I don't know, every new product, we expect that an iPhone has great features every year, right? So, and it will be even faster, right? So it will be, I don't know. And we see custom or companies who exist over, I don't know, decades, and they have struggles. Normally they developed great products, but they have a release cycle of 8 years, and now they have to bring it down to 2 or 3 years because of the pressing competition. And when you have your, let's call it, general tool set to do these kind of product developments in a time frame of 7 to 8 years, it's very hard to adapt for this organization to speed up it.
Yeah, that makes sense. I want to go back to one of the things that you said regarding the FE simulation part. Mm-hmm. Which I think we have to maybe put emphasis on, which is like you have the CAD designers and you have the experts, right? So what that means in practice would be that the expert is generating a workflow, deploys it via Synera run. I think this is how you would say it. And then a CAD designer would be able to use that workflow for his purpose and doesn't have to wait 2 weeks, but he can do it in maybe 1 or 2 hours. Is that how it roughly works?
Exactly. So this is definitely, as I mentioned, probably also the reason why so many from our customers are doing FE automation, because this lead time is, it's wasting, right? It's waste the time. You can use it much more efficient. Interesting is there were, I would say, 2 other technologies also in the market who try to address the same need. And one was, maybe you know, in the CAD software space, you see a lot of simulation tools directly included. I don't know, if you open the SolidWorks, you have a simulation tool. If you open CATIA, you also have your simulation, or NX with SimCip. But if you ask the companies, at least this is my observation, and probably there are also other observations where it's the total opposite. But what I see is that the CAD designer are not really adapting these tools. I mean, for sure, in very small companies, you have this generalistic person who do everything. But if you have more people, then you still, I don't know, they're not really using this kind of possibilities. And even if it's available in the same tool that they normally use for design, they normally say, I hear things like, okay, but this is just limited FE access. So it's not our quality standard. So you cannot set up the boundary conditions in the way that we normally do it. This could be an objection from the simulation department, or an objection from the CAD designer could be something like, I'm only doing it once a month or twice a week, or not twice a week would be too much already, but very infrequently. So it's very hard for them to, okay, they had this one-time training, but it's very hard to, okay, what do I need? Okay, I need material, I need mesh, I need to check the mesh quality and all this stuff. So it's interesting. This, at least I have the feeling that this was not the breakthrough. It was not to solve this problem of the lead time. Another one is to lower it even further with technologies like meshless, right? You see tools like SimSolid, or also with Intact. You see technology where they lower the barrier to set up a simulation setup. But still, what we see, what the industry really wants is they want the same quality they had before when the simulation experts are working, but they want to give the feedback to the designer almost in real time. Probably, for sure, you have to wait the time that the simulation takes place, but they want to eliminate the lead times. And for that, the automation through low code is a a very good sweet spot, because as you mentioned, exactly this is how it's going. The simulation guy is digitalize his knowledge in a workflow, and it's very important. It's not about he do it once and then his job is over. It's very important he takes responsibility for this workflow, because the whole company, the whole design team, the whole development department, they trust these results, right? So it's very important. And this is maybe another shift in the mindset, is that you are not building your automation and you throw it in the pool and say, okay, do it, and it's your case. No, it's really about this. The simulation expert in this scenario has to take full responsibility of the workflow, but he can more or less scale his knowledge, his ability to his coworkers in an asynchronously way, and make it so easy that even the CAD designer, as you mentioned, via Synera Run, can access this knowledge on their own without a huge onboarding, because normally they only need a couple of inputs, right? Normally what is changing is the geometry, and that's it, right? All the other stuff is already predefined by the project themselves on the requirement sheets.
Yeah, that makes a lot of sense. Super smart solution. I have one question. I'm trying to see how I formulate it. There's this thing when we were on university where it's like when you have the academic approach to FE, it's like always you have to solve it as accurately as possible, versus when you go to the industry, it's like how accurate is accurate enough. And do you feel like when you deploy a workflow via Synera Run, for the CAD designers, it's okay to just solve it good enough? It doesn't have to be 100% accurate, because they might not know about mesh convergence studies and things like that. So they just solve it good enough, which again, the engineer takes responsibility for that to be good enough. So it's also industry, ready for the industry, so to speak. So the CAD designer doesn't even need to care about convergence studies.
Yeah, funny. I also remember my mesh studies I did and checked how the conversion changed. I think a little bit depends on the culture of the company also. We see both. We see people say, okay, I'm in a rough concept phase here. For me, it's enough to be 90% accurate. I don't want to be the last, and the last iteration can be done the old way or whatever. Yeah. But there's not the old or the new way, right? You can also use low-code to make a converge or mesh study inside of your automation. You could say, okay, there's another loop inside of your meshing, and say, okay, I want to refine the mesh X times, and I have another routine who checks my quality of the mesh, and only if it's a certain level, I create a report. But I have the feeling that most of the companies, I mean, they're doing simulation every day. They already know what is a good mesh size, what is a good criteria file for their meshing. And they normally have this in their company standards, and they define it, I don't know, a long time ago, and they're just okay with it. It's a different game when you change solvers, for sure. I mean, this is also the reason why we believe in this open platform approach. We don't want to make a huge project with a client and convince them that our solver has the same values as the other solvers. So we say, okay, you're using Ansys, okay, use Ansys. You're using Altair, okay, it's fine for us. Use Altair. So this is definitely a larger, let's call it, step to convince people. And the other one is, as mentioned, other technologies like meshless. We talked about it quickly. For sure. I mean, you get a huge benefit that you don't have to defeature, that you don't have to set up everything so accurately. On the other hand, you get the disadvantage that there's only, I don't know, a certain accuracy, mostly in the 90+%. It really depends on the project and the part. But we see also there a great adaptation, because I mean, sometimes, as you mentioned, especially in the early steps of projects, it's okay to have 90% accuracy, right? You have uncertainty everywhere, so it's okay to be faster than 100% accurate. So normally what you see is then they make 200 iterations with 90% accuracy, and then they make one iteration with industry standards, or at least with the final industry standard.
Yeah, that makes sense. Yeah.
And another one, I mean, everyone talks about machine learning and deep learning, right? Another one, which is also in the FE and CAE automation space, I would think not well established, but a rising star, is reduced order models. So that means if you did a lot of simulation in the past, you can train a model which gives you the results not by simulating stuff, but by predicting. And it depends how much training data you have and how diverse your training set is, but you also get good accuracies here. You can also get close to, I don't know, 90x%. And this also has the beauty that you can get your outputs, which are like normally the we call them outputs, and are normally the result files you are interested as a designer in, for example. You get these very fast, and because prediction is normally done in seconds and not in minutes or hours like simulations, and we have some simulation that even takes days, right?
Yeah. Do you have some of maybe customer success stories that you could talk about in the realm of FE automation?
I don't know. This is a tricky question because now I have to be careful. You can imagine that a workflow or an automation is normally a saved intellectual property, and it's like I always describe it's a little bit like everyone buys Coke and can buy a Coke, right? But nobody really knows the ingredients and the receipt how to build the Coke. And this is a little bit how now the workflow gets understood in the industry. It's a little bit okay. Our customers use this to build their, let's call it secret sauce, how they develop tools and how they developed products. So, but yeah, I think we have some open case studies also on our website where we are able to share. Some of them are, for example, from our great engineering service providers. I mean, they're doing a lot of simulation work also for OEMs and tier ones, and they use it really, really a lot because they can, as mentioned, they can copy and paste from previous projects, and they also can speed up the lead time that they have to their sponsor of the project to get faster feedback, right? And from the other customers, let me think.
I think we can just refer back to the website, I guess.
Yeah.
To throw you under the bus. I think that's more safe. Do you feel like a
good call to action? So check out Synera and then the applications.
Correct. Yeah, I'll link it down in the description for sure. Regarding the future vision, I would be interested. Do you think there will be a world where we talked about utilities, that some people like out of goodwill develop these utilities with you, but that customers might share their workflows, maybe anonymously, like you don't even see like the parameter settings, etc. But at some point that you have a marketplace of workflows. I mean, you guys have templates, right? But do you feel that customers at some point might provide these workflows to other people?
Let's say it this way. This is definitely a point where we do a lot of discovery. I mean, the workflow is also, as mentioned, it's intellectual property, right? Intellectual property normally has a value, and normally not only you, but also others can benefit. A little bit depends how open people are really, right? So I think it really depends on the company. I mean, the service provider is probably more open to share something, maybe to get something in return for that. As maybe an OEM, right? They have a different strategy how to use automation, but they could maybe consume from others. So long story short, definitely, I mean, we started with the marketplace for add-ins, and I mean, low code can be also collapsed into one node, which is probably similar what an add-in is. So we have very intensive discoveries in this field and see, okay, what is the right way to bring these kind of stuff maybe to reality.
Exciting. Really cool. Anything else we might have missed, Daniel, when it comes to CAE automation or FE automation workflows? I think we covered pretty much everything, I think.
Yeah, I think we talked a lot about the pros and cons of automation in the field, which is for sure our sweet spot. Maybe we could also talk a little bit about parametric optimization. I don't know, because this is now normally a low-hanging fruit that you get when you digitalize your processes.
Mm-hmm. Yeah, sure.
I don't know, how's your experience? How many companies are really doing sophisticated parametric optimization where they link different tools?
I have no concrete numbers. I think you have more business insights there than I have.
No, I see. I mean, the beauty is when we do product development is, or not the beauty, one of the challenge, to be honest, is more like you do not know the right number for wall thickness in the initial phase, or if you do this rib design or the other rib design, right? So the best would be you don't define it discrete, you define it more like a variable and say, okay, you can do from A to B or whatever. And then you say, okay, I have my simulation routines. They will tell me if A is better by 6 or A is better by 7. But I mean, this is also my observation in the market is the technology. This is already available since, I don't know, 20 years in the market. There are great tools out there. There's a whole category called PIDO tools. Tools maybe like OptiSlang or Mode Frontier. but the barrier to use these tools is still, I mean, everyone tries to lower it because everyone likes the idea of parametric optimization, but it's still a lot of work, especially when you have then edge cases and you want to do it. So you need first a very robust geometry, which can change without faders. Then you need a very robust pre-processing sequence. We talked about the last 30 minutes about it. So how to automate pre-processing. Then you have to do the solver call. Then you have to do the post-processing. And then you have to evaluate the post results in a way that you can give the optimizer a hint how to change the input variables to change the geometry. And normally it depends on the company again, but I mean, normally you need 3 different people for it. You have the CAD guy, you have the simulation guy, and you have the optimization guy. And they all have to fit together. And there's maybe this one state in the project where everything fits together and works robust, and you spend a lot of money, a lot of hours to make this happening. While if you're already using automation and low code anyways to do your normal, let's call it day-to-day business, it's very easy to also run this sequence not only once, but you can also run it multiple times, right? Yes, you can just say, okay, instead of me changing the input of the design, I can ask my designer, okay, give me 10 different designs, or give me even a parameter which I can change programmatically. And therefore you can, I would say, with low code, you can also lower the barrier a lot to performing these kind of parametric optimizations. This is a nice added value. It's not the thing that, okay, everyone use Synera for that or use low code for that, but I see a lot of people, they start with this and everyone tries at least this out and they also see value in it.
It's perfect. Yeah, maybe we can also add some resources to that so they can check it out. Or maybe just get in touch with you, Daniel, via LinkedIn or via email.
Or maybe, I mean, probably parametric optimization is enough for another episode here on the podcast.
Probably. Yeah. The good closing remarks. So maybe we'll have a second episode in a couple of weeks on parametric optimization. But yeah, really cool. Daniel, thank you so much for talking about this topic. And yeah, as I said, I'll put every relevant source or asset that people might be interested in the description so they can check it out. And yeah, thank you so much and hope to see you in part 2.
Jousef, it was a pleasure. Thank you so much. I really like this format and all the best with the podcast.